if a function may be defined or undefined at some point A, but defined on some neighborhood of A. For example, looks like this, or looks like this, or looks like this. In this case, we have the limit x approaches A, f of x equals L. But f of A is undefined. So we have a gap here, or we have a small hole here. But in this case, equals L, and L, equals f of A. F of A is defined, and this limit equals and in this case, it exists, but f of A is defined, but they are different. So intuitively, the behavior of this function is discontinuous in graph here, or in domain at here is discontinuous at A. It's discontinuous at A, but continuous at A here, continuous. Okay. So when we talk about limit, we never concern the values of A, of the f at A. May be defined, may be undefined, but we don't care. We just care the behavior here. Because if we know this shape, then automatically some values A will correspond to this position A. So this leads to this the following definition. We define a function f is continuous at some point A. Okay, continuous at some. If you see the textbook, you will see notations related to math object will be used italic. And if we are defining this terminology, this will be used the bold-faced. 就是说，你看课本就知道，当我们一个东西跟数学有相关的时候，我们是用斜体字。那当我们正在定义某个东西的时候，这个名称这个术语就会用粗体字来表示啊 ，bold-faced, italic。Aha, this means, this limit exists. F is defined, f of A exists, and these two numbers are the same. Exactly this case. Okay. So in this definition, in fact, we need this equation, in fact, indeed, requires three conditions. What? One. This limit exists. Two. This number exists. Three. These two numbers are the same. Okay. If this limit does not exist, we can't have this equation. If f is not defined at a, we cannot have this equation. If this exists and this exists, but they are different, we cannot have this either. Okay, so one expression indeed needs the existence of the limit and the value of f in a. Well, suppose this exists like this one and this one, but f of a is undefined or is defined but different from this limit. In this case, we will give this, yes, if f is not continuous at a, then we say f is discontinuous at a. So, in this case, f is continuous at a. Not continuous. Not continuous. Good. But these two cases, this discontinuity and this continuity are called removable discontinuity. We give, if the first statement is satisfied but discontinuous, we will say this kind of discontinuity, removable discontinuity. Then we say f has a, oh no. So we have this terminology. Okay, suppose f is discontinuous at some point a, but the two-sided limit exists. Then we say f has a, just give this phenomenon description, the name, removable discontinuity. Sometimes some problem asks you if f has some removable discontinuity at A, please define f of A or redefine f of A such that f is continuous at A. For example, here, f is this undefined at A. If we define f at A to be L, then it becomes continuous at A. Already continuous. Or here, we redefined already A, f of A redefined. More precisely, if we consider another function, g and f are the same, except at the position A. And the g of A is here, means redefined. Means redefined. Because redefined, the value already different. Of course, you can call the new function again f, but you have to know the original f passed away. I mean, not passed away. Before, but now the new one is f of A is already there. Redefined. Okay, redefined. So the removal means we can keep almost all behavior of the f fixed as before. We don't change or define or redefine. Just change f at A. Okay, to make it continuous. This kind of discontinuous is called removable discontinuity. Okay? Just like before, sometimes a function whose behavior around A maybe looks like this. Or this. In this case, from the right equals f of A, then we say, again, we give this phenomenon the name. F is continuous at A from the right, or continuous from the right at A. Oh, from the right first. Yes, very intuitive. Yeah, right? Very intuitive. And this continues at A from the left because minus is L, not F of A. Okay, similarly we have if F is, if this condition is satisfied, then we say that f is continuous from the left at A. Okay. So sometimes the limit does not exist, but one-sided limit maybe exist. Two one-sided limits maybe exist. Okay. If one-sided limit exists, one-sided limit exists, but they are not equal. Just like this case and this case. We also give this phenomenon a name, one name. F has a jump. Discontinuity at A. Jump discontinuity, see? Jump. Jump. Okay, so when someone told you a function which is discontinuous at some point A, but is removable discontinuous at that point, you know, oh, like this one or this one. F has a jump discontinued at some point A. Oh, means these two one-sided limit at A exist, but they are different. Like this one, okay? I think I had better stop here. Thanks for your listen.